Okay, we're on section 6.2, parallelograms. Before we talk about a parallelogram, let's talk about what the title of this chapter is about, actually, and it's quadrilaterals. Let's write that down. Quadrilaterals. I don't think I mentioned that in the 6.1 lesson. We talked about polygons and angles of polygons. We didn't really talk about quadrilaterals much at all. But on this section, we are going to talk about a specific type of quadrilateral. Now let's just talk about this word quadrilateral. Quad meaning four, lateral meaning side. So quadrilateral is a polygon with four sides. So that's what most of this chapter is about quadrilaterals, which are polygons with four sides. Well, we have a specific type of a quadrilateral. Any type of figure that has four sides would be considered a quadrilateral. So if I just did this, I just did some crazy shape like this, no rhyme or reason to it, that would be considered a quadrilateral because it's got four sides. It doesn't matter if it's convex or concave or anything like that. I could even do one like this. Let's see if I can. Maybe not. Can I do a concave? Nope, that's four sides right there. I don't know if I can or not, but that's okay. A four-sided figure is a quadrilateral. Let's talk about a parallelogram. Well, a parallelogram is a specific type of quadrilateral. So right here I have a parallelogram. So let's see what a parallelogram actually is. Well, here's a definition. I don't usually put the definitions right up here because I don't really want you to have to memorize like definitions and things like that, because I think you memorize them for a test or something, you forget about them. I want you to understand what it actually says, but I think this is important. We're going to have, this topic is not very difficult, but there's a lot of stuff to the topic. So take good notes, write down anytime I put a definition or a theorem down, make sure that you write it and draw the picture as well in your notes. I think it's very important that you do that. So let's take a look at the definition of a parallelogram. Parallelogram is a quadrilateral. Okay, so we said it's a specific type of quadrilateral. What's true about this quadrilateral? It says both pairs of opposite sides are parallel to each other. So that means that this side and this side, they're opposite each other, so they're parallel to each other. Now it says that both pairs of opposite sides are parallel. So these two are parallel, and these two right here are parallel to each other. It doesn't say equal or anything like that. We'll get to that in a second. But the definition, so I put it in a different color right there, the definition of a parallelogram is a quadrilateral, four sides, that both pairs of opposite sides are parallel. Not just one pair. That's something else. We'll talk about that in another section. But both pairs. These two are opposite, they're parallel. These two are opposite, they're parallel. That's the definition of a parallelogram. Now that we know the definition, we're going to go through a series of theorems right here that tells you even more stuff about a parallelogram. Every one of these things I'm going to draw right here is a parallelogram. So this theorem, I didn't even number it because I don't care that you memorize the numbers of these theorems. Okay, I just want you to know that this is one of the theorems that is given here. There's actually 1, 2, 3, 4 of them that we're going to talk about on a parallelogram. It says if quadrilateral is a parallelogram. So I'm saying, okay, this is a parallelogram. So what do I know so far? Before I even look at the second part of this, I know it's a parallelogram, so I know that these two sides are parallel and these two sides are parallel. And how do I know that? Because the definition just told me that those opposite sides are parallel. But there's something else. There's quite a few things we know about this parallelogram. It also says that its opposite sides are congruent to each other. So the opposite sides are congruent. Let me just change things around here. Okay. And what do I mean by congruent? They're equal, obviously, so the opposite sides are equal to each other. So I can say this is equal to this one, and this one is equal to this one. So if I gave you a problem where I said that this was 7, and I asked you to find the bottom one, that'd be pretty easy. You wouldn't have to do any math at all. That would be 7. What if I said that was 3? Again, you look over here, and that would be 3. Now, you know they're not going to be that easy. They're going to give you stuff like this. They're going to say this is like 3x plus 2, and this is 5x minus, 5x minus 1 or something like that. And then they'll say solve for x and find the length. And so again, what do? This is stuff that we've been doing all year long. So here we go again. We're going to do the same kind of thing, but we're doing it with a different type of a figure, different type of a shape. And so what do? If they're equal to each other, you set them equal, solve for x, plug it back in, you can find the length. So that's the same kind of stuff that we've been doing all year. Oops, didn't want to get rid of all that. That's what they're going to do here. All right, is there anything else I can say about that? That's pretty self-explanatory, I think, don't you? That the opposite sides are congruent or equal, if you want to say equal to each other. So far we have two things. We know that they're parallel. Let me put that in there. We know that both sides are parallel. Right there, both pairs of opposite sides are parallel, and both pairs of opposite sides are also congruent or equal to each other. Okay, here's another theorem. It says if a quadrilateral is a parallelogram, okay, so if this is a parallelogram, if they tell us it's a parallelogram, what do we know about its opposite what? Angles. The opposite angles are congruent to each other. I put letters in here to make it a little easier instead of saying this and that. So the opposite angles are congruent, so that means that angle A equals angle C. So those are opposite angles. See how they're completely across from each other? These are not opposite angles. They're consecutive angles, consecutive interior angles, in fact. We'll talk about that here in a second. And so the opposite angles are equal to each other. So when you have a parallelogram, the opposite angles are equal. Or if you want to say congruent, you can say congruent. By the way, I should have done this right at the beginning of this lesson. We have a symbol for parallelogram. The symbol for parallelogram, guess what it looks like? Looks like a parallelogram. How about that? All right, so that would be the symbol of a parallelogram. And how do you name a parallelogram? So if I put the letters right here, if I was going to name this parallelogram, let's put this right. Let's put this down here. Okay, if I wanted to name this parallelogram, I would call it parallelogram A, B, C, D. You could actually call it several different things, but you start at one point. I just decided to start at A. And you could go any direction. It doesn't matter. I went from A to B and then C to D. Once you go in one direction, though, you have to go in that same direction. You got to keep going around. So watch. If I went from A to B, look which way I got to go. Then I got to go to C, and then I have to go to D. So if I start with A, then I go to B, I have to go to C. I can't skip over to D. I have to go in consecutive order right there. So that's pretty important to know about parallelograms. So what else could I have called this? I could have called it, I won't write all these down, but I could have called it parallelogram. If I want to start at A, I could have called it A, D, C, B. Could have gone in that direction. It doesn't matter which direction you go as long as you go consecutively. Don't go A, D, B, C. You can't go scattered like that. You got to go A, D, C, B. I could have started anywhere. I could have started at D if I wanted to and call it D, C, B, A, or I could have gone the other way and called it D, A, B, C. You get the idea. I just think it's kind of nice if it looks like this. You start at the left-hand corner and you just go clockwise. It's just kind of a nice, consistent way to do it. But there's all kinds of different ways that you could name this parallelogram. All right, let's get back to this part of it. The opposite angles are congruent to each other. Now remember, what else is true? Let's list all the stuff that we know so far. Now, by definition, what's true by definition? Well, the opposite sides are parallel. This is just review. We're going to do this on every one of these. The opposite sides are parallel by the definition. By that first theorem, what did it tell you? It told you that the opposite sides were congruent to each other. So these two are equal to each other, and these two are equal to each other. And this theorem right here told us that the opposite angles were equal to each other. Okay, here's another one. It says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And I guess I should have put the letters in here again. Let's use the same letters, be consistent. A, B, C, D. And it says the consecutive angles are supplementary. I kind of made mention real quick on the other one about the consecutive. Well, I said consecutive, but I didn't talk about the angles. Anyway, what do we have here? Remember what's true about this? These two lines are parallel. This would be considered a transversal then of these two parallel lines. So if we have two parallel lines cut by a transversal, look at this angle right here and look at this angle right here. They are consecutive interior angles, okay, by the parallel line thing. Remember we talked about that a couple chapters ago. So we already know that parallel lines cut by transversal, the consecutive interior angles are supplementary, and that's how they got this theorem. Okay, it wasn't much of a stretch. So these two are supplementary. Now remember, the opposite angles are equal, so angle D is equal to angle B, and angle C is equal to angle A. All right, so these are consecutive interior angles, and so are these. Look, I've got these two parallel lines right here cut by this transversal, so these two angles are consecutive interior angles to each other, so they are supplementary. Again, just as a review, what does supplementary mean? It means that they add up to 180 degrees. So whatever this angle is and this angle is, they add up to 180. And you kind of know what they're going to do, don't you? If they made it real easy, they would say that this is 50 degrees, and they would ask for angle C. So how would you do that? 180 minus 50 is 130 degrees. That'd be one way they could do it. Or, like I said before, they could have made this, 3x plus 2, and this be 5x minus 1. And what would you do here? You wouldn't set them equal to each other. They're not equal to each other. They're consecutive angles. They're consecutive interior angles. So you would add them up, set them equal to 180, and then you could solve for x and plug it back in and find whatever the angle is. All right, I don't know if those would work real nice and pretty or not. I just made those up. All right, so there we go. So that's one more thing. Let's do some more review. Remember, these are parallel, and why are they parallel? They're parallel because the definition of a parallelogram by definition. Then we had a theorem that said the opposite sides are equal to each other. And we just mentioned this, that the opposite angles are equal to each other. And the latest one right here, the consecutive angles are supplementary, or they add up to 180. All right, let's look at this one. This looks a little different. You say, wait a minute, that's not a parallelogram. It doesn't look like the other ones, but it actually is a parallelogram. It says, if a parallelogram, so this is a parallelogram. And I thought it kind of looks like a rectangle to me. I always thought that shape looked like a rectangle. Well, it's only a rectangle if one of the angles is a right angle. We'll talk about rectangles a little bit later on. Not today, I don't think. But this one says this. If this is a parallelogram, and again, why is it a parallelogram? Well, because if both pairs of opposite sides are parallel, these two are parallel and these two are parallel, then it's a parallelogram. And it can look like this, okay? You can have a right angle in here. That's perfectly fine. But this thing says if it has one right angle, then it has four right angles. So if you were only given that angle B was a right angle, I can automatically say that A, D, and C are also right angles. And why would that be? Well, for a couple of the theorems that we've done before. Angle B and angle D are opposite angles. So what's true about opposite angles? They are congruent to each other. And look at B again. B and C are consecutive angles, they're consecutive interior angles. So what's true about them? They're supplementary. So what's 180 minus 90? That's also 90. You could do the same thing here, you could do the same thing here, or you could say A and C are equal to each other, all kinds of ways to get angle A, and there you go. If a parallelogram has one right angle that's given to you, then that means all the other angles have to be right angles as well. Okay, here's a quick, simple little example that we're going to do. And you're given that this is a parallelogram. They put the parallelogram symbol there, so you know that this is a parallelogram. So let's basically just find all the missing stuff. That's probably the best thing to do. So let's find all the missing stuff. Well, if this is 3, then the opposite side has to be 3, because we have a theorem that said the opposite sides are equal. If this is 5, then this is 5. All right, if this is 128, then angle S is 128 because the opposite angles are equal to each other. Here's the only one that's maybe a little bit difficult to do, is to find angle R. To find angle R, what's true about these two angles right here, Q and R? Well, they're consecutive interior angles. So I would go 180 minus 128 because remember, they're supplementary. These two angles are supplementary. And that would be a 2 and that would be a 5. So that would be 52 degrees. That's the only one you had to do any math for, because this one right here I can find because the opposite angles are equal as well, so that would be 52 degrees, and that's about as easy as that one's ever going to get. All right, they're going to be a little more difficult because they're going to put some values for X and Y and all that kind of stuff, but that's just a real simple little example just to show you how to find some missing angles and missing sides. Let's take a look at another theorem. This says if a quadrilateral is a parallelogram, okay, again, this thing right here is a parallelogram, then its diagonals bisect each other. So what am I talking about as far as the diagonals? We've mentioned diagonals before. They go from one corner down to an opposite corner. That would be considered a diagonal. And then from here to here, that would be another diagonal. So those are two diagonals of this parallelogram. What does it say about the diagonals? It says if a quadrilateral is a parallelogram, then the diagonals do what? They bisect each other. So let's put some letters in here, A, B, C, D again. lack of creativity, and then we'll just call that x for that middle point right there. So it says they bisect each other. So that means AC bisects BD, which does what? They bisect each other, which means they split each other in half, okay, or into two equal parts. That means AX and XC. Do you see this line right here? It splits AC into two equal parts. So this line is doing the bisecting. This one is being bisected. Well, they bisect each other. So now this one right here, AC, is bisecting BD. So that means it splits BD in half, or to two equal parts. So those two are equal. Now, we have nothing that says that AC and BD are equal to each other. Okay, we'll talk about that some other time with a more specialized type of parallelogram. So they don't necessarily equal each other. BD and AC don't necessarily equal, but they do split each other in half, okay, if you want to think of it that way. They cut each other in half. So there you go. So what if I told you that, let's just make something up. What if I told you that AC, or the length, or the measure of AC was, I don't know, 12. And then I asked you to solve for AX. Okay, that would actually be pretty easy. So if AC was 12, remember, these are diagonals of a parallelogram. It's being bisected, so AX must be half of 12, so it must be 6. So that would be 6, and that would be 6. You get the idea. Okay, here's another one. I told you there's a lot of theorems in this. They're not very hard, okay? They kind of make sense, but there's a bunch of them. So it says, if this is a parallelogram, this quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. Let's just do one right here. Let's just do one diagonal. Let's not do both of them just yet. Okay, this works for the other one too. I could do the same thing with the diagonal with AC. I'm just going to do this one just for the sake of time. It says it separates into two congruent triangles. So that means that this triangle right here, ABD, is congruent to this triangle right here, CBD. So these two triangles are congruent. Well, let's try to figure out why that is possible. Well, remember, this side is equal to this side is equal to this side, and look, I don't have to know anything about the angles. What is BD on both triangles? It's congruent because of the reflexive property. So check it out. These two triangles are congruent because of side, 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 and that means the corresponding angles are going to be congruent to each other as well. But it's just a very simple way to show that the triangles are definitely congruent to each other. And the same thing works if you do AC. I'm not going to do that one though. Okay, we'll finish up with this example right here. We're trying to solve for x, y, and z. There's an x right here, there's a y, and there's a z. So that's what we're trying to solve for. Well, there's also a y up here, right? So where do we start? Let's start with the x right now, okay? So I've got a 5x here, and it's opposite this 27. Remember, this is a parallelogram. They tell you, I didn't write it down, but they tell you that QRST is a parallelogram. You have to know that. You can't make any assumptions about it. So they do tell you it's a parallelogram. So what can I do with the opposite sides then? Well, I can set them equal to each other. So I can take 5x, set it equal to 27, divide both sides by 5, and I can just keep it like that. I could keep it as a fraction if I'd like, or you could put it as a decimal, and I believe that's 5.4 as a decimal. All right, pretty simple. All right, let's take a look at y. Let's solve for y. Remember, it's a parallelogram, and look, I've got a y right here. Oops, daisy. I've got a y right here, and I've got a y right here. So let's take a look at the relationship between those two. Well, remember, the diagonals bisect each other, so that means that this segment is equal to this segment. Couldn't be easier. So 2y minus 5 is equal to y plus 4. Subtract y from both sides, add a 5 to both sides, and y is 9. Very, very simple. Let's do one more, and we'll be finished. Let's get rid of these. And let's now do z. Z is just about as easy. Look at this angle right here. That's got the z in it. Now, we have to find a relationship, though, between this z and another angle. Well, what are the only other angles I know? I know some angles up here. I know that's 95, and I know that's 33. Which one of these are we going to use here? Remember, these are parallel lines, aren't they? Parallel lines, and then this would be a transversal. QS right here would be a transversal. Look at 33 and look at 3Z. They're alternate interior angles, okay? Go back a couple chapters. It's alternate interior angles, and they are equally to each other. So 3Z equals 33. Divide both sides by 3, and Z is 11. Pretty simple. That's kind of the stuff that you'll be doing. It might get a little more complicated than this, but it's the basic idea. All right, that's all I have for that, and good luck on that lesson.